Hello everyone. Welcome to the solution of LeetCode problem 349 named intersection of two arrays. In this problem, we are given two integer arrays num1 and num2 and we have to return an array of their intersection. Each element in the result must be unique and we may return the result in any order. Suppose in the first example, we can see that the first array contains four elements, which is 1, 2, 2, and 1. And the second array contains two elements, which is 2 and 2. Now, we can see that the element 2 appears in the both first array and in the second array. So we have to return the output 2. Now, in the second example, the first array contains three elements, which is 4, 9, and 5. And second array contains 5 elements, which is 9, 4, 9, 8, and 4. So we can say that 9 and 4 are presented in both of the first array and second array. So here we have to return 9 and 4. I hope you understood the problem statement as well as the examples. Now the constraint are the array length can be in between 1 to 1000 and the array element can be in between 0 to 1000. I hope you understood the problem statement. Now let's move on to the algorithm. Now, for the sake of simplicity, we have taken the first example. Here, we are given two arrays. The first array contains three elements, which is 495, and the second array contains five elements, which is 9, 4, 9, 8, and 4. Now here we can see that the element 4 presented here in the first array, and the element 4 presented here in the second array, and the element 9 presented in the first array, and the element 9 is presented in the second array. So we can say that the intersection of these two arrays will be the element 4 and 9, because in the intersection, we will take the element which is common in both of the arrays. So in this problem, we have to return 4 and 9 as a list. Now, the problem is how can we get the intersection elements? So we can use set data structure to solve this problem. Basically, the algorithm is we have to take two of the set 1 and set 2. Now, why we are taking the element set? Because according to the problem definition, we have to return the list which is unique. That means no other element in the list can become 2 or more times. Or we can say that every element in the list should be unique. There should be no repetitive element. So we know that set contains all of the element one times. That means in a unique order. So to maintain the unique property, we are using the set data structure to solve this problem. Now, the algorithm is pretty simple. We have to insert all of the element of the first array into the first set and all of the element in the second array into the second set. Now, if I insert the element in the first set, the set will contain the element 4, 9, and 5. Now, if we insert all of the element in the second set, the set will contain the element which is 9, 4, and 8. So here we have seen that this first set contains all of the element of the first array, and this second set contains all of the element of the second array, but it does not have any other repetitive element. That means in the second array, 9 appears 2 times, but in the set, it only appears 1 times. So here, now the problem solution is, as we have taken two elements or the two sets, now we have to run a loop from left to right of the first array. Now, in each iteration, we will check whether the current element is presented on the second set or not. If the current element is presented on the second set, that means we have to add the corresponding element to the answer list. Suppose now we have to run a loop from left to right in the first input. Here we are using the loop in the first set. Now our first element of the set is 5, right? So we have to check whether the element 5 is presented on the second set or not. But we have seen that in the second set, there is no element 5. So we can say that the 5 cannot be an intersection element. Now we are at this element 9. So we have to see that whether this element 9 is presented in the second set or not. So we have clearly seen that this element 9 is presented in the second set. That means we can conclude that this element 9 is one of the intersection elements. So we have to add element 9 into the resultant array. Now we have to check the element 4. So here we have to determine whether the element 4 is currently presented in the second set or not. So we have seen that the element 4 is presented on the second set. So we can conclude that the element 4 can be one kind of intersection element. So we have to add the element 4 here. Now we have completed iterations in all of the element in the first set. So we have found the list 9 and 4. So that's it. That's the algorithm. Now let's wrap up the algorithm. Now here we are given two sets, first and second. We have to add the all element of the first list into the first set and all element of the second list into the second set. Now we have to run a loop in the first set and we have to check whether the corresponding element in the first set is presented in the second set or not. If it is presented in the second set, that means it is an intersection element and we have to add this corresponding element to the resultant array. Finally, we have to return this resultant array. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named intersection. It has two parameters, vector 1 and vector 2. Now, we are taking an answer list to store the answer, and we are taking two sets, first and second. Now, in this loop, we are inserting each element of the first array into the first set, and here we are inserting each element on the second array into the second set. Now, we are running a loop from the first set, and we are checking whether the corresponding element in the first set is presented on the second set. If it is, that means we have to add this corresponding element to the answer list. Finally, we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we are using loop to iterate the element in the array. And the space complexity is also big O of n because we are using set data structure. And in the worst case, the size of the set can be equal to the size of the input array. So we can say that the space complexity is also big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.